Welcome and thank you for watching this short video on lead-acid battery basics, brought to you by STS Instruments. The beginnings of the lead-acid battery that most of us are familiar with dates back 156 years when French physicist Gaston Planté invented the rechargeable battery. While some improvements were made by another French physicist in 1881, Gaston Planté is considered the father of the lead-acid battery, and a scientific award was set up in his honor after his death in 1889. Even after all this time, the lead-acid battery remains the most widely used rechargeable battery in the world by far. Like any battery technology, lead-acid has both advantages and disadvantages. Among the advantages are proven and mature technology, a wide range of size of power levels, including maintenance-free or seal types, best price performance per kilowatt hour and long life cycles, over 97% recycling of lead, and massive existing infrastructure for manufacturing, transport, and recycling already in place. The most obvious disadvantage, of course, is the relative high weight compared to other battery technologies caused by the use of lead. There have, however, been some gains over time in reducing battery weight. When it comes to battery applications, they are too numerous to list. We are all familiar with the battery in our car, for example. The type used there is called an SLI, which stands for starting, lighting, and ignition, as it powers the starter motor, interior and exterior lights, and powers the ignition system. But there are many more applications of lead-acid batteries than cars, as is shown on this list. Let's turn our attention to the actual makeup of a battery. As you can see in this picture, a battery consists of a number of components. The protective case encapsulates all components and protects them from the environment. Inside the battery, there are 6 cells or battery elements, each consisting of a set of plates separated by a separator. The plates are immersed in electrolyte, which enables them to function. Individual cells are connected to each other using straps to form a series connection. The 2 outer cells have terminal posts. Finally, a cover is placed on top with an outgas valve if the battery is not sealed. A closer look at the actual battery elements shows they are covered by a lead peroxide material. The 2 sets of battery plate packs, one positive and one negative, are sandwiched together but insulated using a separator. Each set of plates is connected to the top using a post strap. Each set of plates is placed in one of 6 cell cavities that contain the electrolyte. If you take all these elements together, they look like a familiar SLI car battery. Batteries designed for other applications such as motorcycles or lawnmowers may have a slightly different mechanical layout, but the general constructions for all lead-acid batteries is as described here. Each cell produces about 2 volts DC, so 6 cells make up a 12-volt battery. Other configurations such as 3-cell or 12-cell exist as well. During the actual manufacturing process, the plates in each battery element or cell have to be formed. Forming is the electrochemical process that converts the lead oxide paste that is applied to the plates during manufacturing into 2 different active ingredients, lead dioxide on the positive plates and porous metallic lead on the negative plates. Once the plates are formed, the battery is ready for use. Plate formation has an impact on the ability to test the battery plates for potential defects. This means quality testing is best done after formation to obtain higher fault coverage during production test. Since the battery elements are the most critical component of the battery, ensuring their proper construction is of key importance. Latent separator defects can result in premature battery failure, shortening the life of the battery. Such fault cannot be detected with simple impedance measurements. However, any test method used should also not result in any damage to a good plate, so care should be taken to use the proper techniques. We will elaborate on that in another video called Battery Element Testers Test Methodology. STS Instruments specializes in the design and manufacture of high-voltage surge-type battery element testers. For more information on this type of equipment, watch our introduction to the 1656 battery element tester video. Thank you for watching this video presentation. For more information on battery technology or battery element testers, please contact STS Instruments or visit our website at stsinstruments.com. You can also reach us by phone or mail as shown here.